Okay, I'm gonna do a little short video here, kind of show you my homemade electric retract and what I'm planning to do on the next version. But basically, you've got your, your truing gear in there, and then you've got a threaded shaft that's hooked to the motor, and then it threads through this metal rod that is what actually actuates the truing gear, moves it, and then it all pivots. It goes back and forth through the slot, and that's how it works. And then you've got your your main pivot, which is making this out of 5/16 steel rod, or that's 8mm. Then you've got your rod, your actuating, little short actuating rod. This one I made with this is stuff I got from Home Depot. This is if I can point to it. This is a 1/4-inch steel rod, and then this is a little bushing, bronze bushing that they actually sold. Sorry about the videography here. Anyway, this is a bronze bushing that is a 1/4-inch inside diameter, 5/16 outside, and it's 3/4 inch long. And the truing gear is also 3/4. So anyway, that all matches real well. And then I'm using a 4mm threaded rod for the actuating rod. This one's too short. This is just a bolt I had. I'm ordering some fully threaded rods so I can make them as long as I need. They need to be about 2.5 inches long. That's the this center rod here. This little 3mm bolt that goes all the way through I'm using that just as a homemade standoff. I'm ordering some. I have some standoffs that'll be exactly 3/4 of an inch wide, and they'll be threaded for 4mm bolts. So they'll go in here, and then I'll just put a 4mm bolt in from each side, countersunk, similar to this. This is a 3mm bolt here, but I'm going to go 4mm on the final version. So that's what holds it together. And this, the aluminum is just, of course, is just L-shaped aluminum bracket that I've cut to shape, and then drilled some holes and made the slot. And it's as simple as that. And the trim block it looks kind of like this. Here's a different one that I made that wasn't right, but it's 3/4 inch wide. It's got the 8mm. This is a tube, but 8mm pivot. And then what you do is you have to make this slot. You have to make this slot 8mm also. Sorry, it's hard to do this. Anyway, the slot here is 8mm wide. Then you put your little feet on each end, and that's what, when the rod comes out here and hits this end, that's your end point. And then when it pivots this way, the rod comes out and sits on here. I didn't design this, I'm just copying. Looked at several different ones that I have and picked the qualities I liked from each one, kind of combined them together. Trying to keep this turn block as simple as possible so that it'll be cheaper to make. But this is some stout stuff. This is 3/4 inch. It's 60-61 aluminum. It's not gonna, and it's not gonna bend. But anyway, I'm planning on, hopefully, eventually, when I get the design I like, I'm gonna have these CNC made in China, and by sending them a CAD drawing, and they'll be fairly inexpensive, but they'll be good. They won't be these. Some of these are cast, and of course they'll bend right through here and break across here, stretch. This width here will stretch out, but you take extruded 60-61 aluminum. It's not the hardest that's available, but it's readily available and it's inexpensive, and it's much harder than those cast parts that a lot of them are made out of. Anyway, and then what I glued this in, but I'm planning on drilling a hole, and tap, and put a grub set screw in here so that you can loosen that and remove the pivot bar in case it gets damaged. That can be removed. It also make the retract easier to take apart, because if you can just remove a set screw, slip this out, then the true-in bar will just come right out. A true-in block. Anyway, that's the basic design. This is a motor that I bought from Servo City. It's a quality, it's only $10, but it's better quality than some of the smaller ones. Where is that other retract? Here's, give you this an idea. This is something I bought off Hobby King, and it has heat shrink around the motor, but you can see the difference in size. I mean, this is way beefier, and the gears in this are just kind of just crammed in there. With this motor, all these gears are contained inside this housing here, and they're pretty easy to work. You can take it apart, put it back together, which is nice. But anyway, this motor is only $10 from Servo City, and it's a 500 RPM, works on 12 volts. So it's the gears are pretty solid. I haven't stripped them. Some of these other cheaper motors I bought off of Amazon and paid $10 for were actually smaller than this, and the gears, they had a similar housing, but the gears were weak, and when I ran them on like 14 volts, when it bottomed out, it stripped the gears, so that's worthless. And then this one, I've run this one on basically 4S LiPo. It's really too fast on 4S, but when it hits bottom, it doesn't strip the gears. Anyway, what I'm doing, and then this is what I'm using to control it. It's up and down. What all this is a little double pole, double throw switch I bought off of Amazon. I bought like a bag of 5 of them for $3 or $4, so it's real cheap. And then I'm powering it with what amounts to a 3S LiPo. I've just got this plugged into the balance port that will give me 11 volt, the 3S LiPo voltage. Anyway, so here I'm going to show it running. Got it on a paper plate so it shows up better. I put this strut in it. This strut has a quarter 28 stud, tapped into the strut and down into the true-end block, and that's how it's held together. And then I'm planning on just going and using that. It's pretty easy to do, but then also adding a grub screw, 4mm grub screw here, and then one in the true-end block, so that once it's put together, you can tighten those up and lock it in place. Oh, and then one other thing. Right now, okay, this is a piece of quarter inch aluminum, 6061 quarter-inch aluminum. It's not as in the future, I'm going to make it full width all the way from here up to the top. That's why I made this hole. And so there'll be 4 bolts holding it in place, and then that's what the motor mounts to. And then there are 2 bolts holding the motor, which those could be countersunk if I needed the clearance, but I don't. And then let's see. Oh, the other thing, when I make the when I get the threaded rod long enough, I'm going to put another quarter-inch aluminum block at this end, and what it'll do, it'll you know, really tie the sides together real strongly. It'll be about the same size as this, 4 bolts holding it in, 2 from each side, and it will have a hole in it for the end of the 4mm threaded rod to go into. Now, it won't thread in because you just want it to spin, but it'll be a bearing there. It won't actually need a bushing or anything. I'll just make it the right diameter, and it'll sit there and spin. But that way, the threaded rod will be supported at both ends. It'll help. It will tie. Like I said, it'll tie. There'll be 4 bolts here. 1, 2, 3, 4, and it'll tie. So it'll tie this side together. I made this because I thought I would have a standoff on this side, but you only need a standoff on one side. This side needs to be open so that so it can rotate down into there. Anyway, so I'm going to add this other block, and it'll support the end of the threaded rod. So, wow, 13 minutes. Can't believe y'all listened to me for that long. But anyway, here it is. I'm going to run this thing. And keep in mind, this trim block is not the right geometry, so it doesn't, you know, the thing isn't moving the way it should, you know. Oh, one other thing is that instead of a standoff here, I'll probably make an aluminum block here, because the way these things work is when they get to this point, they butt up against all the other these designs I've been looking at. They butt up against something, you know, part of the housing right here. So if I put another block here, then when the instead of just a standoff, a block or a standoff, either one. But anyway, when the arm rotates up like this, it will bottom out against that, and so that will be a stop on the downside. And what that allows you to do is you can move it, you be able to move it back and forth, and if you need an 80-degree retract or an 85-degree retract, you can just move it closer, and so then when the true end gets up to about this angle right here, it'll stop. Or if like on a P38 main gear, they need a 100-degree rotation from horizontal here past 90, they need to go all the way to 100 degrees, so you can move the block, the stop out, and then that'll allow it to rotate further. So, and then on the downside, when it rotates downward, it's not as well. It's actually, you know, retracting the gear. It's not as critical because your strut could bottom out against something to support it. But when I have this block here, what you can do is make the block a little bit larger, a little wider than you want it, and then you can notch, like so. When the strut comes down, when it gets to the point where you want it to stop, you can go in there with a Dremel tool and notch out that block that's going to be on this end so that it has a definite stop. And that way there's no play at either end, whether you want to go 100 degrees or 90 degrees or 85 degrees, whatever. You can stop it at that point, and then when you go down here at the bottom, you'll stop it. So that's the plan. A lot of little details to get everything just right, but I want to design something that'll be adjustable. It's going to be big and heavy duty. If I start selling them, which I may, you know, I could see doing that once I get them where they look a lot better and they work properly. But the key is they'll be real easy to work on. You pull a few screws out, and you can just pop the whole side off. And if you need to just replace the Truan block, you can do that. Or if you want to move the end blocks or whatever, they'll be adjustable and repairable, and very easy to repair or replace parts. But anyway, here it is in motion. Right now it's in the down position, you know, gear down, and then and all this switch does is it reverses the polarity to the two things here. And the cool thing about this is if you know, you got those complicated boxes that they sell that can burn out and whatnot. If you have a high-end radio, you can control this with just a channel, single channel. And what you do is you make, and then see, this goes back to center. So you push it one way and you let off, it stops. Push it the other way, you let off, it stops. So you could hook this up to a push rod that had like a slot in it, so that when you pushed it this way, and with these high-end radios, you could do it where you just bump the switch, and then it would work on a timer, and you time the retract, whatever, and set it for 5 seconds. So it's going to hold it in that up position for 5 seconds, and when you hit it the other direction, same thing. Instead of me having to hold it like I do, your radio could do that for you. It would hold the switch in position for the 5 seconds it needs to move, and then it would go back to center. And same thing on the other direction. So anyway, here it is. Like I said, the Truan block is not exactly right, so it's not going, you know, fully retracted, and then it moves too far the other direction. When you gear down, that's about 90 degrees right there, but it'll go way past that. And there again, you can control that stop with a block or a standoff. But anyway, that's down position, up position. And again, when I made the slot, well, actually, I made the slot properly, but when I drilled this hole, I drilled it too close to the slot. So I don't have near the clearance here that I want. This is going to be more like 1/4 of an inch from this point to the edge of the pivot bar. So it'll be a lot stronger. This is only about 5/64, so it's not very much. But it'd be like 1/4 of an inch, then your pivot would be up here. And then I notched this a little bit so I could get it to work. But this will be just a straight slot that'll be, depending on whatever size I use for this, which I'm thinking 8mm or 5/16. and so the slot will be that wide. You'll have about a 1/4 inch between these two, and then you'll have your hole here. But anyway, that's up, and you drop the gear, it goes down, and as you can see, the slot's really, the reason this is stopping here is because I ran out of threaded rod again, and everything's off center. But anyway, you can see if that was going all the way to the edge of the hole, it would fully retract, and then the whole slot is too long the other direction, so the slot doesn't even need to be anywhere near that long. So it doesn't hurt for it to be a little bit long, so that you can adjust it for different movements. Anyway, you can see this works a lot better than the first trial. And then these are heavier duty parts. It's a 4mm threaded rod instead of 3mm. Got a good strong motor. Well, it's the same motor. And just heavier duty parts. These are 1/8 inch aluminum instead of 16. But anyway, those are the changes I'm going to make. But you can see how simple it is to operate. I'm thinking, why even, and it doesn't hurt. Like, I'm going to hold this, when I retract it, I'm going to hold this close. Like, I'm holding it. 1, 2, 3. It doesn't hurt for it to hold a little long. There's not that much electricity running through it. Go the other direction, bottom it out. 1, 2, 3, 4. So it wouldn't have to be adjusted perfectly. So you adjust your radio. You know, if it takes 5 seconds for it to go full throw, set it for 7 seconds, and that way, you know, it runs. You know, it has power for a few seconds longer than it needs it, but it's not going to hurt anything. So it doesn't require any complicated electronics, as long as you've got a radio that'll do it. So that's that. 30-minute video to show a retract, but hey, that's what YouTube's all about, right? Well, it's 23 minutes. So there it is. Hopefully, in a few days, I'll have a really nice quality one I can show you. And I won't have near as much explaining to do, so the video will only be about 5 minutes long. Signing out. Bye.